Good morning, all. In previous lecture, we have seen some examples. Find the Fourier transform or find and hence part. In some examples, for hence part, we are using in some example we are using Percival identity formula, and in some example we use the inverse formula for finding the hence part. So there are two methods hence part to find the hence part value, that is Percival identity formula and inverse formula. So in roughly we have to do some calculation, and after that we have to fix that which formula we have to use by comparing the hence part function with our formula. So now let us see the next example. Find the Fourier transform of e raised to minus a mod x when a greater than 0. Hence deduce that Fourier transform of x into e raised to minus a mod x, that is, this is your fx value, and again in hence part we have to find Fourier transform of x into fx. X into fx is equal to this answer. So now Fourier transform function is given fx equal to e raised to a mod x. So mod x value is x and mod x value is minus x. So put mod x equal to x when x greater than 0. Put mod x equal to minus x. That is, again after simplifying we get e raised to x when x is less than 0. Mod x equal to x when x is positive. Mod x equal to minus x when x is negative. So we get the two values fx equal to e raised to minus ax and ax when x less than 0 and x greater than 0. So here this is your Fourier transform formula. Fourier of fx equal to fs, integration from minus infinity to infinity e raised to isx fx dx. Put fx value here. Fx has two values, so split this integration from minus infinity to 0, minus infinity to 0 and 0 to infinity. In 0 to infinity we have to take this value for positive, and for minus infinity to 0 we have to take this value. So 0 to infinity e raised to isx, fx value is e raised to minus ax, and for minus infinity to 0 fx value is e raised to ax. Now solve this by regular method. Merge these two terms, e raised to is minus a, take x common dx, again e raised to is plus a x dx. Use the e raised to b bracket formula because x power is here 1. So e raised to b integration is e raised to b upon derivative of b. So e raised to is this bracket into x upon here e raised to b value is this. So its derivative is is minus a, this is your constant into x, the derivative is constant only. So because k's derivative is k, so constant into x derivative is k, so constant into x derivative is k. From 0 to infinity, again this is same, e raised to b formula is e raised to b upon derivative of b, e raised to is plus ax upon this is plus ax derivative is is plus a, from minus infinity to 0. Now this is your important step. For having the particular fixed answer, we have to take the minus sign common when we put the infinity value. So take the minus sign common, so a minus is upon denominator as it is. So put put infinity here. If you put directly here e raised to infinity, we get the infinity value. So to have the particular fixed answer, take the minus sign. This is particular, this adjustment is particularly for infinity limit. So for infinity limit, the power should be negative, then only we can get the answer, because e raised to infinity is infinity, so we can't get the answer. But e raised to minus infinity is 0, we get the answer. So take this minus sign common and put the infinity, so e raised to minus infinity is 0, and for lower limit minus e raised to minus 0 is 1 upon is minus a. Then for here e raised to 0 is 1, so 1 upon is plus a, minus for lower limit, as the lower limit is minus infinity, so we don't need to take the minus sign as a common or outside, because the lower limit contains minus infinity, so we directly get e raised to is plus a into minus infinity, that is e raised to minus infinity is 0. So simplifying, we get this, taking cross multiplication, is, this is and this minus is get cancelled, and minus a minus 2a upon a plus b, a minus b, use the formula a square plus b square. Sorry, a square minus b square. So I square minus a square, I square minus a square. I square is minus 1. Simplify this, I square s square, I square is minus 1 minus s square minus s square. That is, take this minus sign common and cancelling this minus sign with this minus sign, we get 2a upon s square plus s square. So we get the Fourier transform of e raised to minus a mod x equal to, that is f is equal to 2a upon s square plus s square. Now we want in hence part Fourier transform of x into e raised to minus a mod x. This e raised to minus a mod x is your fx value. So we want fx of Fourier of x into fx. So there is one important formula which is new to you. So Fourier transform of x fx is, if we ask the Fourier transform of x fx, then we can use this new formula. Fourier transform of x fx equal to minus I into derivative with respect to s of fs. Fs means Fourier transform of fx only. So here use this formula. So here this is your Fourier transform of fx. So f of x into fx, put the fx value and f of fx value. F of fx is your 2a upon s square plus s square, and fx is your, fx value is your e raised to minus a mod x. So f of x into e raised to minus a mod x equal to minus I d by ds of fs value. Fs value is 2a upon s square plus s square. 2a upon s square plus s square. So remember this formula, and whatever we get the answer in previous first half part, put this fs value here and fx value e raised to minus a mod x here. We get the Fourier of x fx answer. So take the minus I into, take the derivative with respect to s. 2a is constant, take outside, and 1 upon s square plus s square. 1 upon s square plus a square derivative is, so use the 1 upon b formula. 1 by b derivative is minus 1 upon b square into derivative of b. So here b value is denominator. This is your b value. So minus 1 upon b square into derivative of b. So b derivative is s square derivative is 2s, a square derivative is 0. So s square plus a square derivative is 2s. Simplifying, we get the answer of Fourier of x into fx. The next example is, find the Fourier transform of fx equal to a square minus x square when mod x is less than a. Take this as a assignment because same example we have solved in previous lectures. Hence prove that, this is your prove that answer. So by seeing this example, just I have explained the important steps. Fourier transform. So this is your Fourier transform formula. Put fx value here. When mod x is less than a, that is minus a to a. Neglect this value. So minus a to a and e raised to isx into a square minus a square. Use UV rule. You can use the UV rule here. In previous example, I have used the even odd concept. So here again you can use the even odd concept. That is e raised to isx formula, cos theta plus I sin theta, use there, and use the even odd concept. Separate out the limits or separate out the integration. We get one integration as 0 and other integration you have to solve by the UV rule, or you can directly use here UV rule. So here UV rule used and we get this answer. Now in hence part we want sine term, because in hence part we use, generally we use the inverse formula. So let us check that we have to use the inverse formula or Parseval identity. So here inverse formula is fx equal to 1 by 2 pi fs into e raised to minus isx dx. If we put fs value here, fs value is in the form of e raised to term. Directly if we put this e raised to function here, and in hence part we can't evaluate the integration, just we substitute some value or we use the substitution method, we get the hence part. So here if you put the fs value here instead of this, because it is converted value of fs, if we put fs value, this fs value as it is, we get the exponential functions in hence part, but we want sine term in hence part. Hence before using the inverse formula, we use the e raised to I theta plus e raised to minus I theta upon 2 formula. This is your e raised to I theta plus e raised to minus I theta upon 2. This is your cos theta, e raised to I theta minus e raised to minus I theta upon 2i. This is your sin theta formula. Use this formula. So for that, merge these terms. Which terms? E raised to isa, e raised to minus isa. Take minus 2a upon a square common. First and third term we merge here, and 2 upon is cube take outside, and this term, second and fourth term, we have to merge here. Now take 2 on denominator. So adjust this 2 in denominator, so we have to take in numerator 2 also. So we get minus 4a upon s square. This formula is your cos as, because theta is here, I theta, that is as is your theta. Then again here you have to adjust 2i. So take not 2i, because I is already present here. So take this I with this bracket, and only we have to adjust this 2. So take this 2 in denominator as well as in numerator. So 4 upon s cube, and this term is your sin theta. So by using the exponential formulae, we have to convert this exponential function into sine and cos term, so that we get the hence part sine cos term. Now use this function as fs value to get the hence part. So here we are using inversion formula. If we use the inversion formula, this is your inverse Fourier transform formula. So after putting, this is your fs formula, fs value, and take cross multiplication, we get the s cube in denominator. And now we can match the hence part, because in this hence part there is a x cube, and by using the inverse formula we get the s cube in denominator.